I'm Dan Dumbacher, and I had two roles on ARES 1X. Early on, for about the first half of the program, as the deputy manager for the ARES project office, and then I moved over to be the Marshall director of engineering for about the second half. Well, early on, to go way back, the 1X idea for the flight test really grew out of a conversation that a few people had to try to figure out what was a good way to get some flight test data early on in the design and development for the ARES vehicle. So we came up with the ARES 1X idea because we could get some of the hardware but yet get a lot of the aero data and a lot of the vehicle system kind of data early on. And when we did that, we first wanted, from an organizational standpoint, the main idea was to get that data and the results and put that back into the design process. And in order to do that, the one thing we knew we needed to do was maintain the tie into the ARES systems engineering and integration role. So we worked to try to keep that relationship, but we also had another dynamic going on in that we didn't have all the workforce needed to do ARES 1X at Marshall because Marshall was already pretty subscribed with the overall ARES 1 program. So we went looking for some help and went to Langley, and they offered to give us some help and to step in and take over some of the activities for ARES 1X, and then we built up the organizational relationships from that. Early on, as we were going through the initial growing pains, we found a few things that needed to be tweaked. So we had I guess about a year or so into the project, we had a session where we just kind of laid all the cards on the table and re-looked at how we were doing things and what was the right way to go about it. When we got through with that, we came out with the mission management team kind of role that would sit at level 2 for Constellation, reporting to Jeff Hanley. And the idea for that was because we had to pull together not just the launch vehicle aspects at Marshall, but also the ground operations from KSC. Langley was helping out with the systems engineering. So we had lots of interfaces, and so the best place we could put them all in one place and bring all those interfaces together was in the mission management kind of approach. And that's the way we went on and finished out the implementation of the program. One of the big reasons for doing ARES 1X was to be able to get a development flight test off, get some data into the design process quickly, but it also had the secondary benefit of demonstrating to a large part of our workforce that not everything had to be operated like shuttle, like a human spaceflight program. So in this mix of cultures where we were bringing people in from shuttle, we were bringing people in from the experimental side, and bringing people in from a research center, and then the human spaceflight centers, we had all kinds of different cultures working, and the interfaces weren't entirely smooth. So we had to go to call kind of a timeout with a lean event and just sit down with a few of the key leaders and say, okay, now, and work through what we were trying to do, why we were trying to do it, get the interfaces more clearly defined, what the responsibilities were and what needed to be done and when it needed to be done. Because we also had differences of opinion of what needed to be done and when to do it. So we spent 9 days, as I recall, at Langley working through all of those details, and then we came out with the mission management approach and further actions to be worked that ultimately led to the model that ARES 1X executed. The way we characterized ARES 1X at the beginning was as a development flight test. Now, we did that on purpose. We did not use the words fast track approach, mainly because there were some connotations that go with that in terms of people thinking that we were going to just quit doing some of the stuff that really needed to be done, or we might cut corners that shouldn't be cut. So what we tried to do was use the terminology of a development flight test from the standpoint that to try to send the message that it's not going to be the same as if a human is riding on top of the vehicle, but yet there has to be some amount of rigor to it because it is an important test. It is important data that needs to be provided to the ARES project and actually to all of Constellation. So we used development flight test a lot. We used lean approach a lot in order to get people to be thinking in terms of and start to question what needed to be done and why it needed to be done so that we got down to what was necessary, but we didn't cut any corners unnecessarily. So we tried to be very careful about not cutting corners. Wanted to make sure we did the right things, but we didn't want to do too much. So we used the words lean, we used development flight test a lot, and those in and of themselves that was part of the culture that we had to work through as part of that lean event, was getting what did we mean when we said lean? What did we mean when we said development flight test? What was success? And how important was it? One of the interesting debates that we had in that 9-day lean event was, what was the definition of success? There was the one version that said that the test had to be just picture perfect and match all predictions. That's kind of a human spaceflight kind of approach. There was the other approach that says, well, if I get the flight test data I need in a certain regime, that's success. There was the other perspective that says, well, you can't hurt people or facilities, so you need to at least you can't damage anything on KSC, and we can't have shrapnel or debris hitting anyone personally, as well as all the working safety that we had to that we needed to go through. So we had to work through all of that. In that 9 days, that was a big part of our 9 days, was trying to get to that level of expectations so that we were all consistent, that we understood what success meant, that we didn't lean too far, that kept us from getting some of the test data we wanted from the kind of the corners of the box, but yet didn't do anything that would but managed our risk appropriately so that we didn't unnecessarily put the project at risk. So we had a lot of balancing to do, and really when it all came down to it, what we were really doing was helping all of us understand what was needed for a flight test in a development sense, and bring a lot of people along that were used to that human spaceflight mode of operation to see that they actually could back off of a few things because you were able to take a little more risk. Now, all that said, we didn't want the vehicle to explode on the pad. We wanted to make sure that it was that if there was a failure, it didn't harm anyone, but we also knew that the test flight vehicle eventually was going to land in the ocean. This was not going to orbit. It was going to go up, give us a demonstration of a certain part of the flight test profile, and then go into the water. And we had to sort through all of that, but that was a big part of the culture. And people use fast track or faster, better, cheaper, or some of those words, and we really had to work through a lot of that because the connotation that a lot of our workforce had was, well, when you start talking lean, that means you're going to start cutting things out that we need. Well, we had to work through that, and I think what we ended up with were a lot of people that got to learn with this flight test hardware program what they needed to do and what they didn't need to do, and now they have a little bit better judgment factor in terms of what to apply and how to apply it on future programs. The customer-supplier relationship within ARES 1X to ARES and the rest of Constellation was, to be honest with you, a little rough all the way through, actually. There was always the one sense that I don't need that flight test. I've got my mathematical models. They're good enough. We're wasting all this money on this flight test. What good is that? There was the other version of, I need to do this flight test to help validate the models. And in all of that, we ended up, again, this kind of goes back to that culture conversation too, again, is that relationship, that was actually another part of the reason why we had to do one of those key interfaces that led us to the 9-day, let's relook at ourselves and how we're doing things, because we wanted to make sure that the data that was coming out was going to be usable, and that the user community was getting the data they needed to be able to take the full next step in the design and development. It was the analysts and the designers and the system integrators and the operators all learning what needed to be done and what didn't need to be done through this experience, as well as getting the data we needed to inform the flight test program, or to actually inform the development program for ARES 1. In ARES 1X, it was the first opportunity to implement the technical authority kind of role or model that had been developed and do it across multiple centers. So not only were we doing something new to a lot of people from a technical management aspect, we were also doing it across centers. So one thing that helped out was after we got through the initial and got settled on the mission management team model, and Langley had the lead for systems engineering and integration, they actually took the lead and suggested, this was a Langley idea, to have a joint center management council that included Marshall and Langley to talk about the issues and the progress to help manage the whole project get to a good place, or get to where it needed to be. Along with that, Langley also asked Marshall to provide the chief engineer from a technical authority aspect to basically be resident at Langley, serve as the overall technical systems engineer, and that worked exceedingly well. It had lots of growing pains, but in the end, I think it was exceedingly successful because it helped build the relationships across the centers. It demonstrated the ability of the technical community to start to learn better how to balance the technical with the cost, the trade, and the cost, the schedule, and the risk, so that all of that came together. And in the way we had Joe Brunty set up as the chief engineer, from Marshall, working at Langley, helped bring the right context together. Now, where we did run into some issues that we had to work through over time was the JSC management, the mission management role. The technical authority model that they were familiar with was a little bit different than Marshall. The Langley model was a little bit different. So we had a lot we had more expectations to understand and more things to work through. And it was, on the surface of it, people looked at it, rightfully so, and said, boy, this is becoming a hard problem. The schedule was forcing a lot of the problem, because the schedule was over there in the back of everyone's minds, keeping the pressure on to move things along and to get finished with the technical debates in order to help maintain the schedule. So going through it, for a lot of people, it looked really rough. It was painful. A lot of people put a lot of work and a lot of travel in to make this work. But I think in the end, when I was walking around talking to a bunch of them after the successful flight, they all realized how much they had learned and how much they appreciated the different perspectives that came to the situation to help solve the problems. And in the end, I think it was a good thing. And like Doug Cook says, we've got the 400 people now who have lived this. They've been through the hardware. They know how this works. Now we've just built that experience base that much better for the next system, and it helps this is the kind of thing we need to do continually in the future to help bring the human spaceflight mentality that has been exceedingly successful in the shuttle and Apollo era, and bring it along to the point where we start asking ourselves, what do we need to do, why do we need to do it, and get to that efficiency thing and find the right balance so that we can continue to fly our missions in the constrained budget environment. One of the things we did with ARES 1X was we worked on what needed to be done from a test and validation standpoint versus other programs that we were all familiar with. The one thing you learn is that Mother Nature and the hardware are key, and you can't fool Mother Nature as much as you try. Mother Nature has a wonderful way of keeping us all honest. In that light, there were certain ground rules that you found you had to do from a testing standpoint that you would do no matter what you were doing. You need to make sure that all the electrical circuits are working, that the ones and zeros from the software are going to the right place at the right time, that all the connectors are on, that all the fluid systems are up and running, and that they can fail, that any of your failure systems are prepared, and you have the right redundancy in the right places. All those things you need to do. The question was how much and to what environment. And we ended up finding a lot of areas where we found hardware that was designed for a certain set of environments, and we were actually going to use it in a more stressful environment, so we had to make sure we did those tests. But we also found that the environments in some places that we were going to use the hardware in were less than what it had been designed for. So we had to account for that. So as opposed to a just blanket go test everything to the environment you're going to do, because of the schedule, because of the cost and the budget, we had to work through what tests did we need to do, what did we not need to do. Fundamentally, we did every kind of test one would typically do to deliver a hardware program. It's just a matter of how much and getting the right environments. Now, lots of different programs have tried different things. Some have tried to cut tests out, and they've all paid for it. Some have put tests in and maybe grew the cost, but it was a risk mitigation issue for whatever reason in that particular project. Certainly when you have humans on board in a human spaceflight shuttle launch, you have to make sure that everything's working right, because the devil's in the details, and the details are where we get in trouble. So you have to do a lot of testing and make sure you understand a lot of the details, because the human life is so precious. When it's just a development flight, then I can start to back off on that. And it now becomes a judgment call as to what do I need to do and what do I not need to do. And you bring different people with different experiences in to help you with those decisions. And it all ends up playing out. But fundamentally, you end up doing the right kind of tests anyway. And there were a couple of things on ARES 1X that I think some of the technical people were worried that maybe we cut a little bit too far. But in the end, it seemed to work out okay. So, but that's all part of what we're doing. This world we live in is everything's a compromise. So we're just all trying to find the right compromise. Key lessons learned. Number one, we can always do more than we think we can for the budget. Now there's a floor to that, but I think ARES 1X proved to a lot of us that we really can achieve things hard. We can meet hard challenges on a short schedule and be successful at it. ARES 1X is one of the prime examples, and I have lots of others. But the one thing that I am always impressed with is that the aerospace NASA workforce, when given a challenge, they step up to it and they solve it every time. We don't always get it technically right. We don't always get it management right either. And we have our failures. and some of them pretty spectacular and pretty costly in terms of human life. But I think in the end, these kind of challenges all make us better, make us smarter, and makes the country stronger from a workforce perspective. So I think one of the key lessons learned I've got out of this, again from ARES 1X, was put the challenge on the table, help give the people the tools to go execute it, and then get out of their way and let them go execute it and help guide them along the way every now and then when they need it. And success will happen. And I think ARES 1X is testimony to that. Some of the other lessons learned that are a little bit lower level are, number one, when you're setting up a major project like this, spending a little bit more time up front on what the interfaces are, what the management scheme is, what those relationships need to be, what data needs to pass across interfaces, where are the interfaces, and minimize the interfaces are all key lessons learned. That is absolutely essential. And I think to take that one step further, one of the big lessons learned for me out of ARES 1X was the need to really make sure that the management scheme and operation is clearly understood among everyone before you get too far down the road. You will evolve it along the way. You will make changes along the way. Management scheme has to evolve with the project life cycle. All of that is true. I think one of the things we could have done a better job of on ARES 1X was have a more explicit, open conversation about what the management scheme would be and then stick to it. And I think that was one of our hard parts. The other thing I learned out of ARES 1X is that we were actually early on in a major culture change in terms of how to deal with a development flight versus a human space flight. And that culture change is not something that you write out an equation for and say, here it is, and everybody says, oh, yes, we understand, and then they go off and implement. The culture change is people. And it takes constant communication, constant search for new ways of doing things, constant curiosity in order to continually work through that, because we're all products of our experience, we're all products of our background and the scar tissue that we have from the mistakes we've made along the way. And the challenge is to help everyone learn from those mistakes, but don't get so bound up by all the scar tissue that you can't do anything. So those are some of the key ones. In my new role as the program director for the new Space Launch System and the crew vehicle, the exploration crew vehicle, a lot of the lessons learned we've just talked about in terms of recognizing the various cultures, working through those cultures, understanding the interfaces, understanding the management scheme, are all things that we're trying to have more conversation about up front and early and document so that it's more clear to everyone and that we get to a better understanding of common set of expectations and objectives. We have a lot of work to do on that. We have not been as successful at that as we would like, and we know that. But we're certainly trying. I think all of this communication, particularly at this level and at this time, the communication aspects that we learned out of ARES 1X are particularly important. The other thing about ARES 1X that we've learned is that we really can do things in a more affordable manner. And that is less meetings with less people, stay focused on the work, get the right interfaces, minimum interfaces, all those kinds of things help set up the conversations for what we need to do as we're setting up the interfaces between MPCV and SLS and how we're setting up the interfaces between the programs and headquarters. All those interfaces that we have to deal with, and figuring out which ones we need, which ones we don't, keep them to a minimum set, and work through that. That's all a lot easier said than done. But I think certainly a lot of the folks at all levels that have now been through ARES 1X, now when you, instead of getting into a debate like we did at the beginning of ARES 1X about, well, what do you mean by that? And, oh my gosh, you're going back to faster, better, cheaper, those kinds of debates. Now when you're having that kind of discussion, you say to someone, well, kind of like we did ARES 1X. Oh, okay, understand. Got it. So that experience with ARES 1X has helped in key places. People have a better understanding and appreciation for what it means to look at lean ways of doing things and better ways of doing things and managing your risk all at the same time. So we're trying to take advantage of that. I think one of the lessons that we are learning is that our affordability issues are do not require technical solutions necessarily. Our best ways to make advances in affordability come from how we manage things and the way we conduct our business. And ARES 1X gives us a good example of how to go about that in a leaner approach, more efficient approach. ARES 1X isn't the best answer. I think all of us would tell you that if you gave us a chance to do ARES 1X over again, we would find ways to do it even more efficiently and possibly quicker. But it still gives us that experience base to work from to go to the next level, and we really need more of them. We need more opportunities like ARES 1X to be able to continue this experience base, and most importantly, to help build the experience base of the workforce that we have today that, in all honesty, most of our workforce has been hired since Challenger and Columbia, when, from a human spaceflight perspective, we got much more risk averse. And so we have to help bring them along from that risk averse posture into a posture that's willing to take a little bit more risk, and that's where the affordability will come from. We'll make some mistakes along the way, but I think we can find ways to operate more efficiently, and 1X can give us that big key data point to start the conversation. What I'd like to pass along to the next group behind me that will do a better job than I do, and the next generation, is do more of this. Let's do more. We make more progress building hardware. We make more progress testing that hardware. We make more progress flight testing that hardware, not just from a technical sense, but from a programmatic sense. The visibility that we got from ARES 1X across the country, and particularly with our stakeholders, may not have saved Constellation, but it sent a signal to people, to the congressmen, to the representatives, and to the other stakeholders that, NASA, when they put their minds to it, can find ways to do things more efficiently. We need to do more of this, not just from an external aspect, but we need to do more of it so that the younger next generation of the workforce coming in has this experience base to work on, and then NASA as an organization is living off the fruits of that experience for a longer period of time, as opposed to waiting to do something like this late in people's careers. So, number one, do more. Number two is spend more time up front working on those interfaces and those management relationships and the cultures. Spend a lot more time on that. I wouldn't put the whole project on hold to get it, but pay more attention up front, try some things out, test them, see how they work, be willing to change it. I think one of the problems that we ran into early on with ARES 1X was we established a management model. It kind of got locked in for political purposes, and people were afraid to change it. and and it led to a 9-day, let's get serious, we got to go fix this, that maybe we didn't need to have if we had been a little bit more flexible up front and said, okay, let's try things. If it doesn't work, let's do this, let's do that, as opposed to, well, I can't make those changes because my center may not like it, or whatever political reason there might be, and try to get the politics separated out of it as much as possible. I mean, I enjoyed my 9 days at Langley, but I don't really want to go through that again. In the future of how we might apply ARES 1X even to the commercial crew, commercial cargo kind of operation that we need to get implemented, I think it's key. The culture question is the key in my mind, and I'm honestly worried that we're not spending enough time really working through the culture of what needs to be done and what does not need to be done. I think we're going to have human life at stake. We will have the reputation of the agency at stake, the reputation of the country at stake. I don't want to. The last thing we need to do is overburden the commercial crew operators to the point where it becomes so expensive that they cannot operate in the commercial world. We need to help facilitate them to be able to operate in the commercial world and minimize their technical risk. Let's face it, we're still doing a hard physics problem. We're going from 0 to 17,500 miles an hour in the space of 8 minutes. That's a hard physics problem. With human life at stake. Not to mention all the reputations of the country and the agency that ride every launch we take. So we have to we have to balance the risk in some way. What does that mean as an engineering director at a human spaceflight center, or an SNMA director, or a program manager? To be honest with you, I really don't know. I haven't thought it a whole lot, but I know one thing that 1X has taught us, and that is paying attention to the culture, paying attention to those interfaces, is where is going to define your success. So I would make sure we were putting some attention on those fronts up front now, so that when we got to the harder problems that are going to come in the 2013, 2014 timeframe, we're better prepared to handle the technical issues when they arise, and we're not working technical and culture. We're just basically working technical problems in the future.